record. So we're linking memory. Every time we allocate a Go string from a C string, we need to free the memory later. So this one, we're starting to use a library that you're going to use a lot when you're using with C, which is called the unsafe library. And what unsafe does is basically taking all the safety of pointers that Go's give you and throw them out the window. That's why it's called unsafe. So we define a function called free, which gets a C character pointer and calls the C free function, and we need to wrap it in an unsafe pointer. Unsafe pointer is basically like a void pointer. So you can do everything on it. We'll see other uses of unsafe pointer later. And then in the main, we create the C string, and then we need to defer the free for that one. Then we create the str dupe. We defer the free for this one. We create the Go string, and then we print. So we need to do the free twice when we're crossing from here to there. And again, it works, and this is fine. Now, I think there's no more memory leaks. I'll give it 2 more minutes and find one. So structs. So structs.
Wait, actually go back. Here. Oh, you had the. I was wondering why you didn't have the free day dupe, but you do.
Yeah,
So does the Go string make a copy, or does it just tell the garbage collector?
It made a copy. There's some vague things that I was not totally sure about what's happening there, because there's another place I'll show you where I thought I was leaking memory when I did the free. I actually got a state fault. So, but that was with bytes, not with string. So I think string copies, but the Go bytes does not. It just uses the underlying memory.
Isn't the one inside the string dupe leaking?
Which one?
String dupe. C dupe.
Oh yeah, it should have been. Yeah, right. So when I fixed that, yeah, it should have been.
You said C string.
Yeah, that's my bad. Sorry.
Both
C string and Go string copy.
Oh, right.
Because Go string, you need to, I mean, the garbage collector needs to be able to free it.
Yeah.
And so it needs to make a copy so that it can then be freed.
I think it's also needed for the encoding, because it encodes it as UTF-8 versus.
That's not
It doesn't change encoding.
It's not happening there?
No, but so two things. It could do two things. It could stuff your raw pointer in a string header, because the Go string is internally a struct with the points to data and the length. Or it could actually do a string dip. So in that case, you could have gotten the same effect by calling the Go string directly on your original C string. But that's not the point of this exercise.
So I wanted to do
the only reason it doesn't just stick it in a string header though is because then you would have a string with memory that's not garbage collected, which would be bad.
Yeah.
Yes. Does this mean, by the way, that strings in Go have a size limit?
Yeah, I think currently it's the int is used internally also for length.
So 32 bits?
Length is, so 31 bits would be a decent length.
Yes.
31 bits, of course. In Go 1.1, it can be 63 bits on 64-bit machines.
Okay, but then you pay the strings themselves.
But that's too big, and that's actually bigger than.
Yeah,
that's bigger than the maximum amount you can allocate to the garbage collector.
Yeah. No, it's not said that then you have an overhead for every string of a 64-bit integer, which sometimes for short strings you don't want that. But, lucky for me, I'm not a language designer. Okay, structs. So, if you have a definition of struct, like there's one in std.h, which is the div t, you can use it directly. I'm declaring one here on the beginning of May, doing the div and getting the results, and I can also assign stuff to the members of the struct everything works as expected. So this one is pretty nice. And notice also that %v for printing works nice for structs. So it doesn't know the field names, but it does print the values nicely.
You don't need that that comments up, right? That's just for
Which one?
reference.
Yeah, just
Meanwhile, that's
yeah,
standard label.
yes, yeah, that's just for reference, so we know what's going on. This one is a callback. So you can go back from C, and the way to do it is this is the C code. So callback A is just define a C func, and in the callback.c, which is on the top, we include the _cgo_export.h, which is one that is generated automatically by the cgo tool, and it has all the Go definition that you can do. And then I'm just calling the Go func. So I'm calling Go, and I'm calling the Go func. In the Go code, sorry, I'm including the header file, so I know what's going on. And then I have to do export and the name of the function, just on top of the function. This tells the cgo to export that in the underscore export, cgo export, and C functions can actually use that. And then in function main, I call it the C function, it's going to call the Go function. Now, this does not play well with the Go playground or the present tool because it involves some compilation. But so we can build the stuff, it builds, and we can run it, and you see I'm calling Go, and there's a hello from Go. So we have that. Yeah, so you can do nice thing like that. Note that the main environment have to be the Go one. So the main have to be in Go for my, if I'm not, I don't know if you can actually start the main Go runtime from C. I have no idea.
No.
No. Okay.
It's not principally impossible, but nobody has gotten around to
Yeah.
do
Okay. So you can start from C and go from, you have to start from Go, that's top level.
If you're starting from C and calling Go, then you have other problems.
Yes. Yeah. So a nice thing that also Go gives you is that you can call C when a function in C actually is setting up the error number, the global error number, error no. You can use Go style return value and error, like at the beginning of main.
Oh, nice.
So I'm doing a SQRT of -1, and then if it's not nil, I can print the error, and Go will just use the str error to actually get the error message itself. Again, it's a numerical argument out of the main, and I is not a value. So this is nice. The only thing is you need to be aware which function actually set str error and which ones are not, which is not from. I'm not sure if it's even cross, like if it's in the ANSI or whatever.
So
The example that was at the Go docs before was actually with Atoy, ASCII to integer, and ASCII to integer, at least on my machine, did not set the standard error. So sometimes, you'll get no error, but it's not because there's no error, it's because it doesn't set the right. Okay, case study.
But the error would still be not nil, right?
No, it will be nil then. Because
Always.
if you call C
So
function,
when you call the ASCII to integer on your computer, then the error was nil, but the results were.
no, not SQRT, the A to I.
Well,
When you call it with the string 10, it just returns 0, but it didn't set anything. So, questions so far? Okay, so this is a case study. This is how I learned Go. I just decided to take a library and export it to Go. And I picked Snowball. Snowball is a stemmer. So this is an example. You create a stemmer with a new language. And you know the error here, I know. You take a word, you stem it, and then you print out the result. And then running becomes run. So stemming is basically taking several words and placing it together. It's used a lot when you do natural language processing on text documents. It's good in a way, it's bad in a way because you lose information. So, what else? So, it's not a library. Snowball is just a bunch of C files. I can show you. So you see, everything is here on the same directory. Just all the source file, and Seago is smart. So if there are C files in the same directory, it will compile them as needed. It doesn't know how to do subdirectories, and that's the problem. So Snowball has some kind of directory structure, but I had to flatten it out. So I took all the files, copied them to one place, hacked the import a bit so it will work. And that's one of the things I had to do. But overall, it wasn't that painful to use. So imports the definition, again, we're using runtime and unsafe. We're including standard library and including the lib stemmer, which is the API for the stemmer itself. And the structure itself is basically wrapping the C structure, which is used by Snowball. And I'm keeping the language around because I didn't find a way to get it from the C API. Once you create a stemmer in Snowball, I couldn't find a way to actually extract the language, and I wanted that in the API. So this is allocating a new one. So the function new returns a stemmer and an error, and I'm doing a stemmer there. So I probably have a memory leak right here.
Right? Yes.
Yes. Okay, good. See, that's why I come to this meeting. Another one is up. Okay, so these are two things I need to remember now. Another one, and my memory overflows. So if the stemmer is needed, then it's an error, and I'm returning an error. Next line is important. This one is actually, the go runtime tells you, when I'm garbage collecting that, do you want me to do some additional work? So you can tell the garbage collector, whenever you actually finish this, clean this stemmer thing, call this function free. And the definition of free is below, which is just getting a stemmer and doing a stemmer delete, which is the Snowball way of cleaning up. Set finalizer is a funny function because it actually requires, you see that I'm not passing an interface in free, I'm actually passing the right type. So, and it's a compilation error if you don't pass the right type to the finalizer.
It's a special function.
I guess it's a special function, something like append and friends, which does that. Because I was pretty sure it's going to be the empty interface, but it's not.
Yeah, that's what I was afraid.
Yeah, but no, it's actually typed, which is better for you, so you don't clean up stuff that you're not supposed to.
There's a couple of places where the language sort of does special, like append.
Yeah. So set finalizer is nice.
But those are all built-ins though.
Yeah.
But
something like unsafe.pointer, that's also that's just generated by the compiler when it sees it, so it knows about unsafe. Although there is actually a package unsafe that's mainly for documentation, that's actually completely done by the compiler.
In this case, though, why this only gets run when the program is shutting down, then, right?
No, when the garbage collector is collecting this structure, so I look at the structure when it's being cleaned. If you have additional cleanup to do, that's where you do it.
A finalizer will not run when shut down.
Right, because that would be pointless.
Right.
Yes. I don't know about Go finalizers, but in several languages, if a finalizer actually causes referencing back the structure or things like that, it's called resurrection. Like you're dead, but then we run a finalizer, now you have a reference back to you, so now you're back from the dead and you're actually going back, and then you'll never be cleaned up. So you need to be careful with finalizer, do the minimal work that you have to do. Don't assume anything, because unlike the structures in C++, you have no idea when it's going to run. So check everything. So I'm checking that the stemmer is not nil, I'm checking like You need to check everything.
Or you say we don't know when it's going to be run because the garbage collector might take a while before it realizes that it
Yes.
wants to do it.
Yeah, so in C++, when you have these structures, you can actually count on the order that they're going to run. Here, there's no guarantees.
There are actually other problems, such as it is possible that you could somehow generate garbage faster than the finalizer can clean it up, because all the finalizers run in one thread, and each time it goes into C, it yields to other Go routines. So if you've got a bunch of Go routines producing garbage, and only one Go routine cleaning them up, it'll eventually get out of hand. So the general rule on finalizers is don't trust them.
And
They
make sure it
are
runs fast.
good backups. They're used for like files and stuff as backup, but they still tell you always, you know, close your files.
Yeah.
Same idea.
Exactly. And it's the same, it's not just Go, I know the same thing from Python, from Java, it's the same idea. Okay, so this is the stem function, and so the thing is that Snowball uses something called SB symbol pointer, which is, I think, alias to char pointer, but it's not char pointer, so you need to do some exercise to actually make it work. Otherwise, the compiler. So at the beginning, I'm creating a void pointer basically from a C string, and I'm defining a free for that. And then I'm casting this pointer to be a snowball symbol. And then I'm actually doing a stem. And again, I'm getting an unsafe pointer back, which is, again, a void pointer. And then I'm getting the length back. And then, just before I return, I'm using something called go bytes. And go bytes is converting something from C to a byte array. You have to give it the underlying void pointer and a size. And notice that here I don't free the stuff, because here it doesn't copy. It just uses the memory as is. So if you try to add a free here, things will blow up. So this what happens when you started doing. I don't know if there's more elegant way to do that, but because the Go compiler is actually more strict than the C one, you need to do a lot of conversion and make sure that everything is just right. Otherwise, you won't go there. Which is good.
So I think what you could do here is you could take the address of the first character of word. That's just a valid Go construct. I think.
But I'm not sure if the type will match.
And then you can, since you can turn that into an unsafe pointer and pass it to.
Oh, you mean?
Let me try in the playground.
Hold on, I need to write down.
The playground won't let you run unsafe.
No, but it will let you take an address of the
Yes.
first element of a string. So that would get you the address of the actual bytes that are in there and not of the header. I think I've used that.
I've done that multiple times when using sudo.
So it saves you a copy.
Right. The big issue though is that if it doesn't know the buffer size, you need to make sure that there's a null byte at the end.
Or you can use the len of the string as an next argument and pass it into your C.
Right, I'm saying if it doesn't know the size.
Is there a
doesn't need
guest
to-
network I can use?
Yes.
Yes.
Ah,
Where was I? Oh,
Mm-hmm.
Okay. So, okay, I'll try it with a...
Oh, and has anyone else lost internet?
I found the internet flaky in the last couple of days. I'm on a cable, so I'm cheating. But, you know, I'm doing the Hangout also. So. Okay, so list.
oh no, you cannot take the address of S0. Sorry.
No?
Not of a string, you can only do it of a byte.
Byte, you can do it with
Yeah.
byte, yeah.
Okay, so I can't do that. All right, so I won't. Yeah. Okay. Now where was it? Okay, so this one is list, which is a bad name. I should probably rename it to list languages or something like that. But this is the list of the languages that Snowball is supporting, and it's held in a static array in memory, and it's now terminating. So it's so what I'm going to do here is basically do what we do in C, which start at the beginning of the array, increase the pointer every time until I hit a null, and then stop. And I'm starting with names, which is a slice of strings, and then I'm starting with all this uniptr and unsafe size of. So size is just to calculate what's the size of the pointer, so I can move it again. And then in the for loop, it's an infinite for loop. I'm getting the name, which is again a crazy cast. There's probably a better way to do it. But someone at PyCon told that the biggest thing you can do to a program is stop writing it once it's working. And I think I committed that sin here, so maybe there's a better way.
How you say always, Yagni, no? You
Yeah.
ain't gonna need
Yeah,
it.
yeah, but no, but what he talked about is that once it's working, you leave it, then it's not good. Like you need to rewrite the names, everything. So it was a nice talk. The naming of class. He quoted from songs by T.S. Eliot. So I'm appending the name, and then I increase the pointer and move back until I hit the null. So when you do a go string on a null, you get actually an empty string, and that's how you know you're done. And basically, I'm returning the list of languages. And thinking about that, I could have done it once at the beginning and init, and just keep the list around and return it instead of doing that. So I'm getting good ideas right now.
It seems like it would be easier to do something like make an array and just loop over it instead of increasing your pointer.
I don't know what the size of the array. I need to.
Right,
It's
just
not
make up a size. Say it's 10 gigabytes.
Oh yeah, I know, but it's
And you allocate that amount of memory?
What? No, you just say it's a 10 gigabyte array, and that's the beauty of unsafe, is it won't challenge you on that.
yeah. Yeah. It's unsafe. And that's it, actually. So references, there's the Seago docs. There's a talk called Seago by, I think it's Andrew, not sure. There are Seago examples where you can look. They wrap GMP library, SQLite, I think. There's wrapping, I'm not sure. They're wrapping several C libraries, so you can have a look. There's the Seago wiki, which has some good examples, but also some stuff is not updated. And if all fails, Stack Overflow is a good place to ask questions. Questions so far?
Trade safety. Can I call from a go routine
To another?
to a C library, or like I have to do some thread locking,
No
stuff
idea.
like that?
I have no idea.
What are you saying?
Like if I'm spawning like go routines, now and one of the go routine is calling a C library, and the C library, I don't know, have threads, have other things going on. Like, do I have to do some? Does Go just handle this all by itself, or?
No, I think you have a huge gun pointed at your foot, and so on. I have to. I think if you set num CPUs to 1, you can just pretend nothing's happening.
No.
Yeah.
But if you do actual multiple threads servicing your Go routines, then you're on your own. Well, you're not on your own. You have the You just have to pay attention.
Setting num max procs won't work though because C code does not obey go max procs. So.
Oh, right, sure. Yeah.
No,
So in the C world, you're completely on your own anyway.
Right.
But the Go world won't make your life harder than it already is.
Yes.
If you set num max procs to.
Pretty much just don't if the library is not thread safe, do not use it for multiple Go routines.
It'll be interesting actually for that if or when they change the default from one to more than one, to see how much code we all have written that turned out to not be as high quality as we thought.
Well, you don't have to wait. You can
Yeah.
go max procs and run it and see how it goes.
But it's sort of like most of the Linux programs, so little things people make,
Yeah.
but you don't write because it takes a second to run or so. But as soon as they do that, or libraries people have made, yes, maybe it turned out that all the users were just using it on the low load or with one.
Okay, so this is the end of my talk. Now we're going to hack. We're going to hack on C.
I've got an example I can show of hacking the OpenSSL MD5 library
Okay.
to match the interface used by crypto/MD5.
Okay.
So
we can do that. And after that, the idea was that.
can I show it on your computer though, since I
Mm,
wasn't sure?
sure. Yeah. So.
You have a URL or something?
Yeah, I've got a URL. Gist.github.com.
Hold on.
Is that the thing that the Cloudflare people did?
What?
You can post it on the Meetup
Cloudflare,
page,
they did
Stephen.
something similar. They
Stephen,
I'm not sure.
you can post in GitHub on the Meetup
As a
page
comment.
as a
yeah.
comment.
I don't have internet.
Oh.
Oh, you don't have internet.
Don't you have a? Can you take a cable? Internal cable?
No.
We'll kill the. We are
There's a-
streaming.
There's just
Stephen
one.
MW,
Just one.
STEPHEN,
S.
TEPHEN, MW,
And all?
yeah, slash, and, okay, CEC 20554E, DB 6A 600F52,
600F.
52.
Oh no.
What is it?
Hold on.
This computer machine's on the internet. You want this one?
But still, let's try to get this CEC.
CEC 20554E 4DB.
Oh, I'm missing a 4. Hold on. Where did you go now, my little cursor? Okay. 4
E4D.
This one.
Uh-huh.
Aha!
There we go.
Yes.
Come on,
Where's the
here,
Zen
Steven.
mode?
So,
No, there's a Zen
Steven,
mode.
come here so you can speak near the.
No, hold on. There's a Zen mode, no?
There should be a. Oh, you want to put full screen?
there are two files. Can you scroll down to the other one?
Uh-huh.
Shoot. Okay, so this is the MD5.go, okay?
So pretty much, I tried to make something that I already had a program which used MD5 a lot, and I wanted to use the OpenSSL one because it's much faster
Mm.
than the Go one. So what I did was I took MD5.go from the standard library, stripped it of all the actual code, and then replaced it. So I kept all of the public interface without any of the actual code. So going through just simple include OpenSSL. For the normal MD5 library, it registers itself as a provider of MD5 hash. So I added that. created a struct that's just a MD5 CTX, which is, from OpenSSL. Going down, so the way you normally use a hash in Go is you create a new one, then you write to it, which is the same as as doing an update. Then you call sum, and one of the features of sum is that it does not affect what is currently been read, while if you use the MD5 library, use OpenSSL, when you call finalize, it breaks it, so you'd have to start over. So I first make a copy before, calling MD5 final and then sending it out. A couple issues I saw was, and these aren't really that important in most cases, but the way the hash API is set up is you can avoid allocations when summing by doing by giving a byte slice for in. And what this ends up doing is every time you call sum, it's allocating a CTX onto the heap, and it's also allocating the 16 byte array onto the heap, which it immediately gets rid of when the function ends. So what I did was I made a second version of this, which avoids allocations. First thing I did was I made a C function, which takes a copy of a CTX on the stack and then creates a pointer to it. Because if you create a pointer in Go code and pass it to a function, it will be allocated to the heap.
Unless the compiler can figure out
right,
that
unless the compiler is very smart, and it's pretty smart. I don't
For external functions it gets hard. So all external functions all C
yes.
functions are unsafe.
Yes.
That's on the list of things to do.
Exactly. No matter how smart it gets, it's not going to figure out that a C function is safe.
Right.
So
that means it's actually smart.
Right. So pretty much all this does is it takes a copy of CTX and then turns it into a pointer.
Yeah, just notice that we didn't cover that, but you can actually write C code in the comment. That's fine.
That's
right.
you actually allocated?
Yeah.
Compile it?
Yeah, it will compile it. So if you have sometimes it's more natural to write some helper function and see that actually makes stuff better. And if it's short enough, just stick it there and it's fine.
And then the other thing I did, this is all changed in sum, is I first calculate if there's enough space. If there is, I avoid using append.
Well, I didn't know you could do make and then dot.
So
yeah, that does two allocations, but I figure that if somebody is not passing enough space, then they don't really care about the second allocation, as opposed to if you pass something, I wanted to avoid allocations if the person was using it right, if that makes any sense.
But append does that for you.
The issue with append was that I would have needed to somehow make a slice and then pass it to append, and I was afraid of what that would cause. I didn't know for sure if that would do an allocation or not.
If you make a slice, yes, but append first checks in one instruction if the capacity is big enough to not allocate.
Right. My what I was afraid of was that whatever I was passing to append to make it bigger would end up being allocated somewhere. Does that make sense?
I'm not sure, but we can have a closer look at it.
In other words, in that one, I'm appending and I'm doing a make, which is allocating something. and kind of defeats the purpose.
Right, right.
As opposed to,
I
you know, just increasing the size using slicing. I could be absolutely positive that it wasn't going to allocate.
Okay.
A pen might be smarter than I'm giving it credit for,
No, maybe not.
but
but
I
maybe-
didn't feel like.
But maybe you're, so maybe I don't fully understand the argument. So if somebody passes in a byte that's a slice that's big enough, then append will not allocate. So
Right.
you say if they don't, then apparently they don't care.
I'm afraid of what is being passed to append in order to increase it that would end up doing the allocation. So in order to use append to make sure the
Right.
size is a certain size, I would need to say make an array, do something, and I'm afraid that would create an allocation. If the compiler is smart enough, it could figure out that that's not
Did you
necessary.
profile it to see if it's
So-
actually helping?
Not really, no. I mean, truthfully, it doesn't matter unless that's all you're doing and you don't want to deal with the garbage collection,
Yeah.
and nothing I'm doing is anything like that. It's
Okay.
just I wanted to match the
The CAPI.
right.
You have
I
a branch,
wanted
right?
to match not the CAPI, the Go API.
Oh, the guard.
Mhm.
Sorry.
Yeah. So same idea though, and then it calls no alloc finalize, which is my custom C.
How much faster is this than the normal Go?
It depends if you're using GCC Go. The Go MD5 implementation is much faster. But it's this is still, I think it was still twice as fast or something than GCC Go. Which was itself twice as fast as
Cloudflare made a sort of fancy proxy server in Go, and the guy who wrote it, he had on his weblog where he did not for MD5 but for the regular SSL, where he did the same thing for just the SSL encryption to make it, and it was a good deal faster than the regular Go one too.
Yeah,
So SSL wrapped like SSL Go module wrapped in the SSL C module.
The OpenSSL module wrapped in
Go.
Go instead of using the regular Go implementation.
Yeah.
Of course, now he has to maintain that too, and
Yes.
soon enough, then the Go implementation, I'm sure, will all catch up more or less, right? But for them, it was important because they did everything with SSL.
Okay, so
Cool.
awesome.
That's it.
So anyone has a C library they want to do?
Well, I can talk about something. I can't show any code.
Yeah.
Okay.
But recently I bumped into the fact that encoding /binary was too slow for my bulk encoding, which was really, I didn't need byte swapping. It's a giant array of bytes. It would be really nice if it was just. So I cheated, and I used the fact that the host order and was the order that the file was in. And so the use case is that you have a slice of interfaces, a slice of empty interfaces, but each element is actually a slice of some concrete scalar type.
Okay.
So you have columns of bytes and a column of floats and a column of int64s, and then I have this buffer, and you want to unpack them. It's a bit like the unpack function in Python.
Yes.
And so if you write this in a completely native Go, then you get that the type switch is deep in your inner loop, and that's kills it. So the benchmark I had doing a gigabyte a file like this unpacking with 3 megabytes per second, and I was very sad. And then, so that's when I happened to look into, this was a couple of days before this meeting was announced, or somebody made me aware of this meeting. So I made a C function pack and a C function unpack that are each other's inverse. It takes a slice of integers that are the kinds out of the reflect library, So it's an enum that describes bool, uint 8, 16, 32, or int 8, 16, 32. And it takes a pointer to an array of C structures that I happen to know match exactly what an array of slices would look like. Although I use as little information out of the runtime as possible. And also in the export.h, the underscore C Go export that's generated, a couple of Go runtime types are generated for you, so you can do this in a reasonable portable way. And then in the inner loop, I go over the, and then I pass in a buffer with the raw data, and then the unpack function goes over the program of kinds and just eats out the chunks of bytes according to the same pattern. And now it's 150 megabytes per second, so that's worthwhile. Except if you do strings, because I couldn't be bothered to figure out who was doing the copy or not. If I have a string, I call back into Go and say, here's a slice of bytes that I know is not copied. Please stuff it in this slice of strings I have over here, and then so it looks like a native Go copy of a slice of bytes to a string, which is exactly the only copy I need, and then I can't imagine it going wrong. So that works really well, and if I have some time, I might put it into a library that Rob Pike would not be very upset about. he actually had this post about if you're doing byte order conversions this way, you're doing it wrong. But it's really what I needed. It would already be better if there was a fast path in binary encoding for slices of scalars. Although that doesn't really help when you have actual records with alternating.
And the file format itself, is it a known file format or something?
Well, yeah, I know it,
Okay.
but it's not a public thing.
Oh.
Although a couple of months ago I wrote as a finger exercise a native Go library to read and write netcdf version 1 and 2. That's a format that's used a lot in science, climatology.
Yes.
All the climate models are netcdf files, and 1 and 2 are actually very compact and small and focused designs. And then a committee got together and designed netcdf4, which is layered on top of HDF5, which in itself is this incredibly complex.
It's on top of HDF5?
netcdf4, yeah. So I don't support that. I support the old format, which is actually dates back to the Fortran mentality.
I don't know the HDF5 format specification. I know it's speedy, it's fast. It's
Okay,
really
so
fast.
well, especially the old ones, and the HDF is probably a very decent library, but it was just way too complicated. It has built-in balanced B trees to do indexes, and you can. So it's basically really a file system.
Yes, yeah, it's a file system you have now.
But the netcdf 1 and 2 is just you have a header which describes variables. Every variable has typed attributes. There's some global attributes, and then there's the fixed size data, and then there's the one dimension of your arrays can be time, and that's your record dimension, and within each record it's all fixed size again. So basically, once you know the formula of the file, you can compute the offset of every byte that you might want to read out of there, and then it also comes down to striding through these arrays. So I wrote something that's bit for bit compatible, but if I have some time,
Do you use it? I just looked it up. Do you use it? The CDF library you made?
Not yet. It was as I said, it was a finger exercise. But so the unit test the test is you get the sample libraries from the netcdf website. And then it reads them through the interface, and it writes them out through the interface, and then there's a binary diff, and it's bit for bit compatible. So it's good enough for me.
Right.
But it's not yet super fast. So it's more in the order of 3 megabytes per second rather than 150. And I think with this trick that I did here, it could be made really fast. But for this is good if you have some Go code that writes some data and you want to write it out so that you can read it in MATLAB or
did you try one profiling it to see if reflection was the issue, or
Oh,
if the byte
no,
order
I didn't.
was the issue?
No, I know it's the type switch in general. So
Okay, so you probably could have just avoided the type switch loop
no,
by using the byte order directly.
by using a what?
Can you get the code for encoding slash binary? The
Oh,
documentation.
Even so, then yourself, you have to you have
I
at
mean, it's kind of
runtime.
tedious though.
The record format is only known at runtime.
Okay.
So I have to reconstruct the records. For every I read the record and I have to iterate over the fields in my record. I have a description of my record, and I have to iterate over that and decide. Okay, now I'm decoding a UN64. There it is. Now I'm decoding, and so you're gonna have, if you do it like that, if you have to read it out record by record instead of column wise, you're going to have that type switch in your mostly.
Okay.
So an alternative could be that you say, okay, now I want to read this column of UN64s out of this entire file, and I know I'm just going to run through the file like this. Then you could move the type switch one loop up. But even then, and then you could maybe use the byte order thing, which is now the thing that you pass into binary.read and binary.write. You can use that directly for the simplest atomic types. That still wouldn't be as fast as C thing, but you're right, that would be faster. I think you're right, that would be faster.
Yeah, I only learned about read after I had spent all my time working with byte order.
Uh-huh.
I was making a library for reading PAR2 files,
Uh-huh.
which is a binary file format.
Mhm.
So,
But in general, it's best to get the reading formats right, because it's often hard enough. The hard part is figuring out how the bits are stuffed in there. And then
Right.
once you have that, you can worry about. So for this project where I ran into that problem too, I wrote the binary thing first. Oh, the native Go thing first, and then once I had that working, then you also have a base case to compare against.
cool.
Alright, so we have a little time. We wanted to do a little bit of programming exercise, so thought about picking C libraries and wrapping it. Any ideas?
Everyone choose one or like?
I thought
Choose one or go to, or
I thought we could do all one. I thought if we can find something that we actually think will be value to the community, maybe.
I have the one I sent on the.
Oh, the GIP one.
Yeah.
Yeah, that's
So, but I already did the basics, and I'm pretty sure the only work to do to it is to make the API nicer, which takes for us. Oh, and then it's just mechanically make.
You're missing finalizers. I saw that.
I'm sure I'm missing a lot of stuff.
Yeah. So we can hack on that.
Because it
That's
was the
fine.
first Go thing I ever made, because the other thing, the thing I really wanted to make, needed it.
So do we need this library installed, or is it already?
Yeah, I need it installed. So
Okay. So.
Does it have on Brew? At least on
Probably,
Brew.
yeah.
Search GOIP.
GUIP or lib GUIP.
Yeah, there is on libGOIP. Yeah.
Uh,
1.4.8.
Yeah, that's good.
So how we can do? We clone and then we ask for a pull.
oh, it's a
Merge?
resolver. Yeah, I see that. Yeah. So. If
I don't know. For me, it would be worthwhile if we just you put it up and then you tell me all the things.
yeah.
There are only 2 or 3 functions.
Okay. So let me find it. Hold on. No, this is not the right window. This is the right window. Where's my mouse? If someone could please write me an eye-tracking window manager that knows what I'm looking about and moves the mouse there, that will be great. Just
With the Simplify.
With this, I'm in the brink of writing it on myself with the. I don't know if you guys know about Simple CV. It's pretty impressive. Hold on, which one?
What is it called? OpenCV?
No, it's on top of OpenCV. It's called Simple CV, and it's
Simple
actually pretty impressive. Is this the one you posted on?
OpenCV just looked too complicated.
Yes. So Simple CV is like you said. This is the face. Where are the eyes? And it gives you the eyes.
Yeah, do here, show for.
Oh, all replies.
And then,
Oh, somebody replied to my announcement that I wrote this thing
Which one?
on the NetCDF library.
Oh. Okay. So we are going to do a code review. Not here, not here.
that CDF is for fluid dynamics, right?
For all kinds of stuff, real numbers in multidimensional arrays.
So I like that GitHub lets you actually comment on commits, but you can never comment on a file. So I can add a comment here. I can add a comment for a specific comment.
What we could do is say put it into a GIST. I think we can add comments to a GIST if you want to.
Or I think you can blame it and then.
Yeah, but it will be spread out over. Or
Yeah.
maybe.
Let's see. Let's do the GIST thing. I think.
Is just this file?
So, yeah.
Well. Okay.
So GAP is from the AP, it tells you which geographic location the AP is. And it updates with the whole NIC system. And
There's a company that will mix a file you can download the update. And they have different files. Then the only API I support here is the one that gets the country, but they have different databases for that will give you the AS number or give you the state or try to guess the city, that sort of thing.
So
Is this the same database that Kimru uses for their DNS-based version of this? You know?
Which library is this?
how can I add comments now?
MaxMind?
Oh, yeah.
How can I add comments now?
Maybe again.
Yeah, I can.
you can just edit. And
No, that's
You can, if you click on the line numbers, it doesn't.
no. It just highlights the
that's
line. Come on, GitHub. Really?
seriously?
Sorry, can't do it.
I want my money back.
Yes.
Yes, exactly.
Oh, and yes, I finally got a good answer badge on Stack Overflow.
Good answer badge.
Yes. I guess it's telling me that I've only given
This
one
one
good answer.
here we can actually comment. Where can I comment here?
You can't.
Anyway, so open Emacs or Vim or whatever you're using, and you just go over the code.
Yep.
Yes. Okay. So we have C flags. Is there a way for Seago to use what's her name? There's the there's the C library that you ask it what should be the includes and things.
Oh
like
yeah,
that.
package info.
Yeah,
or,
yeah, something like that.
Yeah, no, I don't think so.
No.
I think maybe if you might be able to do it if you could call package info and then pass in, you could make your own little build script.
Yeah, you can do it with set or something like that.
Right now with the
But that
Gophers.
gets on like I didn't, I think if it was sort of the main program you're making that you're building, that would make sense, but in this one, since it's the library you include from elsewhere,
Yeah.
it's sort of unfair to impose on the users like, oh, just set up this whole build process to build it this way.
You can make something with CMake5, no?
Yeah, but I think it's good.
So that's why here I just
yeah, you just
adding on
enumerate all the libraries there.
until the compiler and all the platforms I needed it on, and then
Yeah. What's the name of the file? GIP.h.
yeah.
I'm just curious.
So you could, All the C stuff doesn't have to be in one file, so you could have one file that emits just the gluing comment.
Yeah,
No.
see, mine is two assigned to.
Wait, what could I do?
So you could have your real code that imports C in one file, and if you want to make your make file generate something, you don't have to edit the file. You can make another package file. That
Oh,
will
that's nice.
Yeah, but it could be an interesting addition to Seago.
But-
Actually,
yeah.
run something and.
right, but you don't want to become the package, the build system for the C
Everything.
But
Yeah, but it's just run a command and get the output and stick there.
There's also the fact that right now, if you build a program, no user code runs. If
No user-
you
yes.
call go build, that's
Yes.
always safe, you know, just
Yes.
assuming that there's no
Yeah,
flaw
but this
in-
one, you know, people saying, like, I always ask, like, do you really read all the code that is in make install before you do sudo make install? Nobody does that, so.
Right.
So that's another
That's the
location for
idea,
you.
is that here, you can be sure.
Yeah,
that
yeah, that
Make
it
won't
does.
be a problem.
Yes. So you can add another location. You assign to. This is Arch. I have an echo. Why do I have an echo?
And probably use a lib too, huh?
Yeah,
Mhm.
probably use a link too.
Quiet can be a constant,
What?
quiet? Or is like, that's a variable?
I think this way then you can set GUIP quiet equals true or false.
Oh, okay. Yeah. Yeah. Usually,
Just about.
who that?
The other, oh, never mind, he joined again.
So, usually it's verbose, not quiet, but that's just, mostly the convention is quite verbose and, you know, reverse
That would make more sense.
That's
You never free CNAME. Looking at 85.
line 85.
Yes. You get CNAME from GOIP name by address,
Yeah,
and you never free it. My suggestion though is to always put your frees in defer unless you're doing it in a loop or something.
So you put them close to.
Exactly. You put them close together, and when you go back and edit it later, you'll thank yourself.
Yeah.
Wait, if you put the defer inside the loop, it will call it only once, or it will call it for each of it?
It'll build up a list of defers to do when the loop ends.
No, not
I
the
mean,
loop ends, when the function
When
ends.
the function returns, right. So that'll be after the loop goes, 1,000 times, it could rack up 1,000 defers. Something you normally would avoid, yeah.
Just stack space.
Another location in my place is again,
Well, stack space and it's
the
not
dat
free
file.
until,
The .dat file is in use share without the GUIP.
Where is it?
It's what was it?
User share GUIP that.
No, this is another,
Yeah.
another location, okay.
Yeah, that's the fun when you're trying to do cross distribution Linux stuff.
it looks like just every time you ended up using c.go string, you forgot to free. Anything returned to you from C.
Right, so you can try to open it up in an editor, and then Steven can tell you what, just so it's not just me trying to type it out until it works.
Huh?
If you do it adding the extra freeze, then it'll be not just me doing.
What's the name of this editing? There's an online anything thingy.
Steve, are you still not on the network?
No, I restarted and.
All good in the hood?
Yeah.
Right.
The one with the App Engine support.
No. Hold on. Where's my memory?
Online code.
I'll find it. Yeah, need
I
my memory.
think Google bought it and turned it off.
No. There used to be one that people used.
Cloud IDE.
Something like that.
Like one that lets you compile it online, or?
No, just one that tells you corrupt to edit.
Just edit it.
No,
Go?
no,
Collabedit.com, although it's not really made for code,
No.
or cloud, or C9.io.
Wait, can you try to edit like spell out?
Just do it in
Yeah, okay.
Etherpad.
Let's do.
Etherpad, that's the one.
Yeah,
Google bought.
that's like the
Yeah,
original.
but there's another. We don't edit here. Super. You see?
You can edit there, but you can't.
Compile and make sure it works.
But we can all wave and get
all
out.
work together, if that makes sense.
How do I?
You would have to, do merging.
Okay. I got it. No worries. Raw.
You can edit it there and submit it as
Yeah.
a pull request or something.
Yeah. Yes. Okay. So. Okay. So we said here is.
I edited that one already.
Oh, you did that? Okay, so this one is done. Uh,
The same here. So.
So you did the location here as well.
Yep.
So
here I'm sure. So here in the down a little bit further down, around 58. That the runtime something to make it clean it up when I'm done.
this one. Yeah. So you have a C string, but you don't free it. Oh, you free the C base.
Like, but you were suggesting I should move that up to.
Yeah.
No, he's using it, so we can't free it right
No,
now.
but I can go to defer.
Yeah.
Do you need that? Like,
You don't have to do the func. Don't do that.
But do what?
Don't make it a function.
Just yeah.
Yeah, just c.free.
No, but
Defer
T-
c.free. There.
okay. So this one.
what do you call it?
What?
Semicolon.
A semicolon.
My God.
Too much Java, Mickey.
So-
It's the other way around, if someone has to go back to C.
It's actually too much JavaScript lately. That's
You don't really need to either. It usually figures it out.
okay. We said about quiet, so we call it verbose. Okay.
But there are a ton of times when he does not free strings that are returned from functions.
Yeah, that's a general comment. Just to go there and.
Yeah.
Okay, so this is get organization.
Is it good?
Yeah, so here again we wanted to do like this, right? And then
This doesn't use CFR.
What? Which
So
one?
Like
you need
GP
to
name
make a
by
close
address.
function
I don't
that
know.
will free up the GeoIP struct.
Where's the new?
What?
This is the new? Oh yeah. So yeah, you want probably here runtime set finalizer. Some
Before making a finalizer though,
I
I
think it
first
needs
make
to-
some sort of a free function,
Yeah, yeah.
a free method.
yeah.
It needs to be a few lines above because they somewhat confusing. It actually returns on line 73 if it works.
Mm.
So God. Here is what we check. So I do it here, okay, and then
And then at runtime, right?
yes.
Because we are
For,
storing in DB
finalizers,
GUP or
normally what I recommend you do is first of course create the free method and then you use a method expression to when you use set finalizer so it calls free.
What do you mean by method expression?
A method expression is when you do type dot method name
Oh, okay.
and it's
Yeah,
and that returns a function
yeah,
or evaluates. a
Oh, so you
function.
set it on the GeoIP.
yeah. So and then here.
No,
It's-
G dot
It's a pointer though.
Like this?
No, in parentheses, put pointer, asterisk, GeoIP.
This. Or,
And
or
then-
but you can do the G.3, right? No? G.3 is also good? Or no?
I don't think it'll accept that, no. That's not a valid expression even in Go.
Hmm. Works in
Well,
Python.
that actually is valid in Go 1.1, I think.
Yeah? Yeah, I use
That's
it.
a new thing.
In
So,
Python I use it like crazy.
what is this function?
So you want open parentheses, star, GeoIP, close parentheses, dot free.
Open parentheses, star.
GeoIP, dot free, no.
Oh, like this?
You need the close parenthesis before the dot.
Like here?
Yes.
Oh my goodness. Oh,
Except
okay.
you
By the way, I checked the runtime set finalizer. It takes two empty interfaces, and it's a runtime error, not a compile time error. So
Yeah.
that,
I thought so.
there's no special support from the compiler.
So,
It's when you call it, it dynamically checks, but it's
oh,
the
so
runtime.
I was wrong.
it's
So
a
I
runtime
was,
error, not a-
sorry, I misled you.
No, that's okay. No,
Yeah,
I
wrong.
was thinking, really, I've never seen that.
Yeah, so I thought the my memory, 3 bits and it's gone, so.
Only built-ins and unsafe have any type of magic.
So, sorry.
So that's how you get
Okay, so.
a reference to a method. Asterisk G, the one that you just did, like the dot free.
Yes.
Okay.
Wait, go back up to it where you were calling it then?
Also, you could just make the original method and this not be a pointer method.
Yeah.
Based on the current type, there's no reason to make it a pointer method.
I don't,
Actually, there would never be a reason to make it a pointer method.
right, it's a copy to the same pointer,
Right.
and then you have 2
I'm saying
types.
it doesn't have to be a pointer method.
No, but if you have 2 copies and they have the same internal pointer to the same C structure, I think it's a
If that happens, then
it's-
you're screwed.
Yeah, that's what I'm saying. But if you specify that all the interfaces and everything returns a pointer, then you know you have just one struct that points to one. It's more clear that you need.
Yes.
Don't do that. So
And your free method should nil db, of course.
yeah, yeah, exactly. Do you want to write the code or?
Well, but it needs to call whatever like here, shouldn't I call whatever it is that the GYP library wants to? It probably has some
Yeah.
function, right?
Yeah.
So I need
Yeah,
to
so
just leave it calling it.
Okay, yeah.
So-
Making a free function though, make sure that if GI is nil, it doesn't do something stupid. Make sure if DB is nil, it doesn't do something stupid.
yeah.
And make sure that it nils DB when it finishes,
Yeah.
so that it won't do something stupid next time. Free is hard. This is why we use Go.
Yes. Okay, so we're now on this one, the get organization. So just as a general comment, I think if it's null, then you should return an error, not an empty string. But that's a design decision.
I think
This is, I think, more Go than, this is more like the C interface.
right. It was I think it was because it was the first thing I did. Now I'm used to the extra
Yeah.
error, but at the time then, because the reasonable way to fail when you're using it is usually that you would say, well, I don't have a country or organization or whatever it is, and it's just an empty string.
But I think the unknown country is at 3 stars or something like that. If you actually give it an IP and it doesn't know, I think it returns you 3 stars instead of an empty string.
Right, they have some, they have some
Yeah.
explicit, they have some explicit weird country codes, but
Yeah. We're using a different GRP library and it returns like 3 stars or something, let's say.
Oh, no.
I don't know.
So we should do that also when we do the open, right? If DB is nil, there's like it's wrong in
Yes, yeah, so.
if you go up, we just
Yes.
print it and we don't know it, right?
Yeah,
Line 73.
yeah, so basically, from here,
right.
that's up to you if you want to change the API or not. But yeah.
Because that would say like you have something
Yes.
that is inconsistent, right?
No, that makes much sense to do, because I think right now then I had trouble testing, well, not trouble, but when I was writing tests for this, then the tests were spewing out all sorts of crap, right, where if I had this just return the
Yeah.
error. I think maybe this is how the quiet verbose thing came in the first place. Actually, was that my program looked through the file names he was trying, and then he would print errors and so on, right? Yeah, really, if it was just returning an error, then the program can decide what to do with it. It's, yeah, I think this is just the ugly from me not knowing what I was doing when I was making it. That's a good point.
No, it is also good for us like to think about the Go interfaces, because returning error, not returning
Yeah,
error.
it's like, in Python they say Pythonic code or not, so it's the equivalent in Go, which I don't think it has a name. Right?
So here on line 98, I think you were telling me I was missing the
We
free tool.
just call it idiomatic Go.
Oh, yeah.
Not Go-ish?
Yes, right, that's it.
What?
So you are missing the, oh, you added that the unsafe scene
Yes.
for free, yeah,
Yeah, here,
right.
yeah,
No, but wait, Go string.
But the Go string
Yeah,
did go
doesn't
also
need
that, right?
yeah. Okay, so getting country again.
thing.
Goish.org is available. It's all you. Goish.org is available.
Ah.
Go-ish?
Go-ish, that's fine. So.
Too bad godoc.org is already.
And again-
taken, although the people who, made the site, I'm not upset.
this is like this one, so it's closer to that one. And then I don't know. So C country is also
Yeah. See, this is one of two actually where if I was making this in Perl, then I would end up with some sort of a function that actually does the calling right, and then I would have some, you know what I mean? I would make something that would build where the code would build the function, since they are 80% the same. The only difference it needs is which particular C function they made. But I don't think there's a way here to do that cleanly.
No, I don't. That's what I found. That also when you start writing with C code, your Go code start not to look so diamante.
It's clean.
It's
Right.
like, okay.
I guess why couldn't I actually have a GUIP lookup builder that takes that then would call another function. Right, so I make a GUIP lookup builder
Yeah.
that would return the right function, and the GUIP lookup builder would take as one of the parameters to take a little bit of code that just does the inner,
Yeah, the inner
take the
stuff.
C string
Yes.
out.
Yeah, so you hide the ugliness sometimes.
You could
Because the problem here is that this stupid library has, I have to git country and the git org someone made a patch for,
Yeah.
but they have like 20 other ones
Okay.
that are,
Yeah.
there are few, and only a few variations. Either they do something with a string or they do something with a few bytes.
Yeah.
And they, you know what I mean? So it's sort of like, that's why I haven't added all the other ones, because it felt just wrong to cut and paste those same
Yeah.
20 lines now.
It would make sense to write this thing in C that returns a Go string. So you will
Yeah. That's what he was saying. He was saying like if he can dynamically have some kind of lookup table to know which C function to call, but all the C functions have the same signature. They get the database and they get a string.
Ah.
So if he has a lookup and some ugly, so you can do that in one place, and then all the main API functions will just say, okay, call this with this C function, and you're done.
You can just auto-generate the whole code,
Yeah, that's the idea.
right? Like you write a little template that generates all of it.
I have a,
In C, like with the nice library, and then you call that from Go.
do that in Perl and Python. So I have a Perl or Python to write some Go code, so use the C code.
And then the shell script to drive it all.
Yeah, exactly. Just have to build it.
I saw once a Prolog program that actually generates assembly code. That was
Yeah, I would like to do that, like to generate the REST API interface, like, but that just generates.
But that's what stuff like protocol buffers and things like that do for you actually. That they take the definition and they generate the code for you.
Right, but that at the moment it generates only like data definition, doesn't generate service definition.
Yeah, that sort of sucks.
Right?
But in Go you can use Gophers and is the RPC package back in? The native Go RPC package? Or is that
I think it's in the net Go still.
we took it out for 1.0, but maybe
The 1.1 is inside?
There's a JSON RPC one, right? Inside.
yes.
Which I found the XML RPC so much more useful because most services that you're going to interact are actually XML RPC and not JSON RPC.
Because usually if you got smart enough to use JSON instead of XML, then you're not using the crazy
Yeah.
RPC.
Yeah.
You're just doing HTTP calls.
Yes.
But JSON doesn't scale after a while. Like after you reach few millions of, you
Yeah.
start 60% of our time right now is deserializing JSON.
But you can use
After 10
you-
million of users hitting
Yeah.
straight, like deserialization goes
what,
dominates everything.
Is it from the browser to the?
It's from from DynamoDB to our cache, and from the cache to our system.
Because I remember last PyCon there was a guy from YouTube talking that they just switched to Bison, which is
Bison,
one,
yeah,
and,
we are
and he said that
investing in
it was
Bison.
so much faster.
Message pack.
Yeah,
It needs to be
no,
dynamic.
he said that they investigated several things and Bison was the right because it's agile, there's no schema, so you can change the schema all the time, but it was really fast and really efficient about compiling stuff.
Actually, that's a good thing.
BSON. It's what MongoDB uses internally for.
But it's
So-
still JSON.
So
though, right?
it's JSON with some extension. It has a date type and some other types, and it's supposed to be super fast to compile.
But why is that the CDF format for the scientific data? Why is that better than storing it in? Look, why do you use the CDF type format instead of using like protocol buffers or GOP or
Because
something?
I don't use it for myself. It was for interacting with other programs.
Because they had
So
already made it that way.
so if you want to do something in MATLAB or then or if
KB
people, it was just something to keep me busy.
Right.
So,
So-
I wouldn't use this format necessarily to store time series myself.
What will you use then?
Well, at Google we used protocol buffers.
Right.
So.
Yeah.
Actually, even if they are not perfect in very many ways, what was the most useful about protocol buffers is that it was the standard way to store all data, and it was sufficiently self-describing, especially since everybody has access to the whole code tree, to be able to read other people's data without having to go and ask them for permission.
Right.
So, and that paid off in ways that were much more important than the actual super optimized implementation.
Right.
So you can do like type C func, which gets C what's it called? And then and then have a, you know, something like
That doesn't look like valid go.
yeah, I know. But
539.
I have no idea how to define a function type. There's some.
Just type C phone
Hey guys, I'm gonna get
space.
going.
Okay. No worries. Thank you for coming.
Yeah, thanks for streaming it online.
Yeah.
It helps.
Always.
Have a good one.
You too?
Type
I'll try
C
and come
phone
next time. Yeah.
Okay.
space phone. There we go.
Okay. And then here you basically do and there's and then
Okay, that's nice.
um,
So what did you used to do with Go, or
Hmm?
someone said you worked on Go, or?
Yes, I worked on the Go compiler.
Cool.
I did, the first thing I did was adding dwarf, so you can debug.
so
Uh,
that's like the calling function. And then,
GDB.
So this is for the GC compiler, not the GC Go. And then I worked something else for a bit, and then I came back and I did inlining and escape analysis.
so you can do stuff like that, and then all your functions are basically just
For the compiler
Just
itself.
doing the
call this, call that, call this, call that, and
Ironically, in all my time on the Go team, I wrote C most of the time.
Oh.
Put this whole thing in a gist, and then I'll put in
Yeah.
the fixes when I get home, and I'll try to make it that way.
yeah. You probably need, oh, you have a DB.
Right.
Yeah, so you have the, yeah.
You need to pass that in.
So
and need to take
now
the
I can
result-
finally
the
say that I
result
met
back
someone.
Yes.
who was on the Go team.
And I wish I had
So-
Gophers with me, but Andrew forgot to bring me a large bag of Gophers.
Oh. Well, hook us up when Andrew comes down next time.
Next time he comes, I'll
So you work at SpaceX now? Do you
Yes.
do Go there too or something else?
So we're just looking at using Go for something, and when I can talk about it, I'll talk about it. We're evaluating it, and I didn't even have to evangelize very much. So someone responsible for something came up and said, "I think we're going to try doing this in Go."
Okay, so
You're like, did you see my resume? I think we should.
okay, so I'll do this, which is
So wait a minute, you are the one who should be able to answer my question though, because you do the escape analysis.
Yes,
Append.
yes. I also did the append optimization.
so I posted it in the
cool.
comments
So
of this meetup.
if I
Okay.
send
The link to this gift.
a
No worries.
a local
Yeah, that's
variable there, is it considered to escape if I append?
No, as append is handled not automatically.
I call this function, I call it like 100 million times a day, so
Yeah.
it's...
Depends on what
I'm
happens
actually this with the memory leak. I
happens
don't really
with
understand because I call it enough that
If I slice
It
an
considers-
array and pass it
Maybe
to
the
append,
smallest is
will it consider that array to have escaped?
like, but,
not
you know,
if you
looking
put
today's
it
memory
on
leak
the
because
on the
most
second
of
part.
there's so many
If you
it's spread
the
over
first
a lot of
argument
different
is
servers,
supposed to come out on the other
it's about
side,
30,
Right.
so-
so
and
it
the
follows
rest
that.
for
So
Lumad, it was getting,
it's
instead
it's
of
not
being
automatically
between
escaping if you
500
pass
and
it to
1,000
append.
requests a second, it was
So
getting
passing it into the
5,000
second
or
part of
10,000
append
requests
is
a
not.
second on each server.
Okay, so I
And it
can
was a lot of them were
fix my
leaking
other
memory.
one
Yeah.
and
But
make
I
it
thought it was
simpler.
just the 32-bit ones.
That
There's
was what I was
also
afraid of.
there's also an
But
undocumented
it's
trick
quite
that the L
possible
flag
that this
gives
is
you
the
more.
making
No,
worse.
not the L flag.
So
The
maybe, yeah.
M flag
Yes.
gives you
Escape
undocumented
information, yeah.
and inlining. So you can have you can check with that, but that's not portable, not guaranteed. GCC Go might come to a different conclusion. Everything will change at some point
Yes.
with the M flag. So,
The B flag is fun too.
what does that one do?
That one disables bounds checking
Oh,
in, the compiled code.
maybe.
Yes.
Oh,
Which, using that sped up some stuff,
really?
yeah. I think it sped up, what was it, MD5.
Huh.
Went faster without the
And
bounds.
what did the inflag do?
It gives more information. So actually, the reason we put it in is so that we could write unit tests testing that things escape properly inline, because otherwise it's really hard to figure out. Because it's supposed to be invisible in code, so it's hard to test that your optimizer optimized.
Does it make sense to add a JIT compiler to Go?
Yes, should totally do that.
Decisions it made during.
Somebody should do LLVM to the
Right?
LLVM to the native Go parser.
Yeah.
Somebody started doing that. That would be fun.
I'll actually have, if we've done, then it's, let's see what you can do before. There's a program I found just a few weeks ago. Yeah. Well, it might only work on a Mac, but there will be something similar on Linux. Search for FS watch, so file system watch.
Oh, FS Watch.
Yeah.
Yeah, so,
That one. Watch. So that's the one. I'm sure there are others, but this is the one I use on my Mac, and this is using the OS 10 API. But how I'm using it is that I will have my editor in one window, and then I have another window where I'm running basically FS Watch, and then the directories that I want to watch, and then go test with whatever parameters I want.
So every time you say it,
Yeah, because before my workflow was edit, switch to the other window, run the tests, look at it, edit. Where now it's just whenever I save, right? Because it means that where before I would test whenever I said I was done, like not more than once a minute, once every 30 seconds, where now every few seconds really, like whenever I'm not sure, I just click and then right away I'll know when I messed up.
So I saw someone who did, I'm not sure if for Eclipse or something like that, but it's basically a save rule. So every time you save, it runs the test suite, and it annotates, the tests that failed in the editor. Yeah, so you do stuff, you do save, you run the test suite, and then you eat like the C errors that you get from the compiler. So you can do that for Vim or Emacs or I'm a Vim user. Does it use iNotify or?
It uses the OS 10 version. He is linking to someone who has the same one for the iNotify API.
OS 10 does not have iNotify?
Different API. FS events, they call
Of
it.
course.
There's a, I forget what it's called now, but someone made a Go package that is sort of like has support all of the different APIs as much as they are the same. So in some programs I've used where I wanted that functionality, because I used to develop on my Mac but deploy on Linux, then I was using that because it was
So how is your workflow now with this tool? Like anytime you save, this will detect that you saved and
run the tests.
you run the test.
And it just shows me, and then, usually then if I have a screen big enough, right, then it just has a window up in the corner, and whenever I can just keeping an eye on if the tests are working, and if that is compiling and so on, right?
And it's so fast that it's...
Yeah, it's plenty fast because it takes less than a, and it takes less than a second, but also because it's a separate process, then if it's a save thing in the editor, it might slow down the editor while it's doing it. Here it's completely separate, so it doesn't, it doesn't get in the way in any way.
This one?
Does it have...
Yeah, this is probably. Yeah. So this one just shows you the status of the tests every time. And this one runs the test. But I saw one that actually did it automatically every time you save, which is nice.
Right.
It depends also of how often do you save and how fast are the tests.
What I had one program where the tests were slow enough that it was not practical, and then I don't know if the regular test system can do it too, but I used a Go check. Is that what it's called? And you can pass a parameter there with a regular expression for the test you want to run.
Oh yeah,
yeah.
yeah, got that.
So I use that to run a test on whatever part of the system I'm working on right now in those programs where it's otherwise too slow.
Awesome.
So your append question, if you pass in as a second argument the slice and ... that's okay.
Okay.
So that's considered safe.
And if I do a make, then that will
always allocate.
Always allocate, so I need to make an array.
Oh no,
That's
actually
the array.
that make maybe that make will be done on the stack if it can figure out that it doesn't leak. So maybe I think make and new are also turned into stack allocations if it can prove that it's safe.
Okay.
So that should be good, but you should check with the -m flag.
Okay guys, it's 9 and I need to kick you out. I'm
Yes.
sorry. Thank you very much.
Thank you.
This was fun. Thanks for organizing.
Yes. And we'll do another one next one?
Yeah. What are we gonna do the next one?
Maybe profiling and debugging?
Ah,
That's good.
Yeah.
And we can see if the inner loop time switch was the problem.
I'll have a look.
I thought that might be interesting. If you have any tips about, how do you work and what do you do, and if you work, I work with GoCode and Vim and things like that.
So what interests me is if you think this